All right, in this first part of this first question, I just want you to create and label a scatter plot and make a residual plot. So if you're making a scatter plot, your x-axis just needs to have a scale. Here, this one's counting by tens. Y-axis is also counting by scale, so you would need to have the scale labeled. You also need to have the variables labeled, your points plotted, and then if your x or y-axis or both aren't starting at 0, we really should show the break in the graph. But that is, you would need all that to get full credit for a scatter plot. For a residual plot, you really don't need anything specific in the way of labels. They really are just looking for a sketch of what does that look like so we can see the pattern in the residuals. So then part B just wants to know, is a linear model appropriate for these data, and explain your reasoning. And yes, it is. We have two pieces of evidence to look at. So it would be sufficient and complete to say a linear model is appropriate. So yes, you should say yes. Because the scatter plot has linear form, or the scatter plot follows, a linear pattern, and this residual plot is scattered with no curve. Mentioning both of those is important when you're talking about residual plots. C says, interpret the value of r squared in the context of this problem. This one is just a straight filling in that statement, and it is in the notes. But 0.967, oh, and by the way, I'm getting r squared is this one. It is that we never use r squared adjusted. So 0.967 is the proportion of variation in fuel consumption that is explained by the number of rail cars in the model. And the reason I chose those, fuel consumption is my y variable, and whatever we're saying it is explained by, that is our x. And then the last part D, says, would it be reasonable to use the fitted regression model equation to predict the fuel consumption for a train on this route if the train had 65 rail cars? And the key to this one is 65 is beyond the end of our data. So our answer should be no. 65 is beyond the range of our data, and using x values outside the range of our data is not necessarily reliable. The term for that is extrapolation. I don't think you would necessarily have to say the word extrapolation as long as you were talking about this idea. But no, it is not reliable to go outside of the range of the data points that you have. And in this one, this is a scatter plot question, but they didn't actually give you the graph. They just wanted you to talk about. They told you that there's a relationship that is positive, linear, and strong. And part A was just describe what is meant. And so the rubric for this year actually gave several responses that were acceptable. So I just put them all on here so you can compare to what you had. So if you were going to talk about what does it mean to have a positive relationship, any of these would work. You could say a positive relationship means that the wolves with higher values of length also tend to have higher weights. You could say a positive relationship means that as length increases, so does weight. You could say a positive relationship means that longer wolves weigh more. And you could say a positive relationship means that the points on the graph go up as you move from left to right. The one note I would add is if you can include context, you're going to be much better off. Almost always they want context, and it certainly, if nothing else, strengthens your response if you give context. Moving on to the second one. For linear, all of these would work. A linear relationship means that as length increases by 1 meter, weight tends to change by a constant amount. That's the key with that one, on average. You could say a linear relationship means the points generally follow a straight line. You could say a linear relationship means that the relationship between length and weight is straight. And you could have said a linear relationship means that length and weight have a constant slope. All of those worked for what it means to be linear. And then for number 3, what does it mean to have strong form? You could say strong relationship means that the points fall close to a line, or a strong relationship means that observed values are close to predicted values. Or a strong relationship means that deviations from the least squares regression line are small. Or a strong relationship means that the correlation coefficient is close to 1. And in this problem specifically, the reason we would say 1 is they've already established that it was a positive relationship. In general, a strong relationship could be close to -1 also, just not in this case because they're told it was a positive relationship. B wants you to interpret the meaning of the slope of the least squares regression line in context. So again, that's right from the notes. So when you go take the test, just make sure those are handy. But here we would say the slope of 35.02 means that for every increase in the length of a wolf by 1 meter, the predicted weight of the wolf would increase by 35.02 kilograms on average. And predicted and on average are important because we're talking about a slope of a regression line. And then C, last part here, says one wolf in the pack with a length of 1.4 meters had a residual of negative 9.67 kilograms. What was the weight of the wolf? Well, the first thing we need to do, because to get residuals, we need to take the actual y minus y hat. Here we have the residual. We're looking for the actual weight of the wolf. So what we need is the predicted weight y hat. So we would plug in 1.4 into the equation. And then really, you are just setting up and solving this little equation. Here's my residual. I'm looking for y. I have y hat now. So add 32.57, and then we get our answer.